Hi, welcome to Making Sense of Complexity, featuring conversations with complexity science practitioners and philosophers. Our goal is to share insights on how to make sense of our complex and uncertain world. Today our guest is Princeton Professor Justin Junge. Justin earned a PhD in psychology from Yale and served in fellowship positions at Harvard, Dartmouth, and Tufts before joining the faculty at Princeton. His areas of focus include the philosophy of science and mind, information theory, brain evolution, probabilistic laws, and the emergence of order. Let's begin. Justin, welcome to Making Sense of Complexity. It's nice to have you.
Thanks for having me here.
I do remember seeing you give a presentation, I think it was about 12 or 13 years ago, on talking about the complexity of the human brain. So I'm kind of excited to touch base with you now and flow that into the conversation on the podcast. So it's just great to see you again and talk to you about these topics again.
I appreciate the opportunity to talk with you.
Yeah.
And yeah, I remember that talk on the complexity of the human brain, and it hasn't gotten any less complex.
I think that's probably the case. So let's start with where are you calling in from?
I'm calling in from my office in Princeton, New Jersey. I'm a lecturer in the psychology department, and I've worked in a bunch of areas related to human cognition and psychology and some philosophy as well.
Yeah, so that's got to be a pretty heady atmosphere. A lot of famous names have gone through the halls at Princeton, so that's a great place to be if you're trying to think big. So tell me what the weather's like.
Weather is unseasonably warm. I guess is the January. We haven't had any snow yet. It's been or almost no snow. We got a little tiny dusting.
Yeah, middle of winter and no snow in New Jersey, so that's a sign of changes taking place. And
Yeah, it's funny. It seems like one of those things where I like the snow, but a lot of people seem pretty happy to have a warmer winter.
yeah,
I often think about climate change, and people focus on the negatives of it, and there are some negatives, but there's also some possible positives. It
yeah,
seems
yeah.
worth change can be good and change can be bad, and I feel like some changes you can appreciate.
Yeah. And you have a couple of kids. Did they get a chance to see any snow this winter?
We had a good freeze right before Christmas, and sort of all the puddles and the wetlands near our house froze, and the kids went out and ice skated on their backsides through the forest, and it was lovely. But we've had no sledding yet.
Yeah. Okay. Well, I hope they get a run at it anyway. So thanks. And I wanted to get a sense of now your background is primarily in psychology, but you've done a lot of different things in that field over the years and spent some time in physics. So I just want to start by asking, what got you into this field? What's attracted you? What's kept you going? Why this?
Well, I guess there's a long answer and a short answer. I'll try to balance with a medium answer. But I've been interested since teenage years in how the mind works. The question that really captivated me is, how does consciousness work? How do we have sort of an understanding of consciousness from multiple different levels, from a transcendent level, from a material level, possibly? Could you get consciousness into machines? And so I wanted to pursue that topic in college, and I tried out a neuroscience lab, and I tried out an animal cognition lab, and I tried out social psychology, and I came to think that vision science was the right approach. And vision science has a really long history of rigorous study of trying to understand how we process information from the retina into visual cortex and multiple different pathways. And the topic within vision is attention. So visual attention, you can have your eyes pointing one way and your attention can be somewhere else. Attention is what you're aware of. And so if we could understand how you can shift your awareness, how you can be aware of one thing versus another thing, and what happens in your brain when information goes from unconscious to conscious. What's going on? Is it a particular brain area that's activated? Is it a particular type of activity? Is it activation in one area broadcasting to the other areas? What exactly is going on when information transforms from unconscious to conscious in the brain? And that was a question that I sort of came across, or the framing of it that I came across during undergrad, and decided that's it. I need to know everything I can about this. And so then I did my PhD in a vision science lab at Yale and focused on that transformation from unconscious to conscious, mostly using behavioral experiments. Though the lab I was in also used fMRI to look at how things were changing in people's brains, but that wasn't my method of choice. I liked the behavioral experiments because you could code them up in a couple of days and get data in a couple of days and potentially answer a question. Within a week from the time you get this burning question, you've got a candidate answer and then follow-up questions. And I was really drawn to that cycle of being able to get excited about a question and possibly answer it while that excitement was still fresh.
So, give me an example of it seems kind of surprising that you can go from question to study to answer in a short period of time when you're dealing with something as complex as vision in the human brain. So, sort of describe how that experimental process works. Maybe an example of something.
Yeah. So, there's lots of different methods that people use in vision science, but one of the ways people study attention is with a task called visual search. And it's a toy version of Where's Waldo. You define a target and you set up some distractors and you say, how long does it take you to find that target? And is it dependent on the number of distractors? And so if you're looking for the letter T amongst a bunch of letter L's, they've got features in common, those sort of junctions. And the more L's that you add to the screen, the longer it takes you to find the T. They call that serial search. So you search one item, then the next item, and the reaction time goes up as you add items. But if I tell you to look for a red item amongst a bunch of blue items, you find the red item right away. It doesn't matter if there's 5 blue distractors or 100 blue distractors, the red item sort of pops out at you.
So in that case, you don't have to kind of scan through the whole field of vision to figure it out. It's just something that you can see right off the bat. So it's quick, right?
Yeah, that's right. So it's as though you have a pre-made attentional filter that will just let that one thing through. You don't have to inspect each. You don't have to shift your attention one item at a time and process them. And so those simple Where's Waldo type experiments, you can control all the aspects of the visual screen using a number of different programs. I think we used MATLAB in my lab, but you do it now with Python and different extensions, and people use a number of different languages. So you can program the experiment. You can change the number of distractors or the type of items or the complexity of the items, the distribution. You can put them in a circular field or scattered randomly about. And those are the sorts of things that, little tinkers you make to the program. And then you run it on yourself. You run it on your lab mates. You bring in some undergrads or some paid people from the community, and you pretty quickly got data that are high quantity of data, hopefully high quality as well. But you can give somebody a visual search task. You can give them 1,000 of them. And what you need for data is either high signal in each trial or just a lot of trials. So you build up signal over noise. And because these tasks can be done rapidly, each trial can be 1 second. It's easy to get a lot of data from each participant.
Yeah. And so what does it tell you about the complex process of, light, eyeball, optic nerve, brain center processing? What are you learning from those experiments?
Well, there's almost too many examples in my head to draw just the right example. One of the methods I was using was something called rapid resumption of visual search. And so the idea with that was that you give somebody a search display and then you take it away, and you put it back and you take it away. It's sort of like a strip, looking at it, it's gone, it's back, it's gone, it's back. And so you can look to see, if I just put the display up, how long would it take you to find it, to find the item? But in this case of taking the display and putting it back up, on some number of trials, you find the target faster than you could have possibly gotten to had you just started from scratch, suggesting that some part of you already knew where the target was and that you're just going back there.
Right.
But if you were to probe people and ask them each time you take it down, where's the target, they can't tell you.
Yeah. So something is stored perhaps in I don't want to call it subconscious, but in a neural field somewhere that, that assists you in the task the next time around, but you're not really aware of it.
Yeah, that's the idea. So that we thought of it as sort of an implicit visual buffer.
Yeah.
That there's information in there and it's still being processed, even though you're not conscious of where the target is in there. Somewhere in your head, it found the target and it guides you directly there the next time the display comes up. And so that is sort of a petri dish or isolated example of information transforming from unconscious to conscious. And so use that as a tool to try to understand what's the capacity of that implicit buffer, and how does that compare to the capacity limits of your conscious awareness? Can you get more information in the buffer than you can be aware of at a given time? Is it the same amount of information, just something else has happened to it? Mm-hmm. Is it detailed information? Does it include the locations and the details and identities of objects, or does it just have like pointers? There's 4 items there, and one of them has a red highlight. That's the target. We don't know exactly what it is, but look there next time. Mm-hmm. And I didn't get all those answers. I sort of set off doing that type of work, and then got interested in other things. And
so that kind of thing gives you insights on what the capacities and the functions are that are working in the brain, perhaps in ways we don't really understand. So it begins to fill in that picture of how the brain processes and filters its attention, and so that's great stuff. Now, I want to go back a little bit because I know I've heard it that the Greeks believed that the eyeballs, sent something out, and that's how they perceived. And I think more, later science would suggest, well, we know now about the electromagnetic spectrum, and we know the retinas and the receptors on the back of the eye. But I know there was some question about, the idea was that the receptors on the back of the eye would send signals into the brain that the brain would interpret. But I gather it's now, there's more of a sense that there's a lot of stuff happening maybe at the eyeball and in the optic nerve that sort of pre-digests the data. It doesn't go as raw data in the brain. Am I correct about that?
Yeah, there's a lot that happens from the retina to recognition. So each of your retinal cells has about 120 million receptors. So hugely high bandwidth amount of information arriving at the part of your brain that's exposed to the external world. Your retina is neurons pointing at the world with the light receptors. So 120 million receptors sampling many, many times per second. And you think about that funneling up to how much you're actually aware of at a given moment. And I think there's a lot of ways to think about that, but one of the examples from vision science is called change blindness. So if you change something about your scene, if you were to change the words in the picture over your shoulder, I wouldn't notice. I've been looking right at it for a long time, but I'm not consciously aware of it. Mm-hmm. And so the capacity limits of our conscious awareness seem really, really restricted. I think about that as sort of a really restricted capacity limit compared to these 120 million pieces of data arriving on each of your eye multiple times every second. And so what's sort of all the steps, all the filters, all the processing that's happening? And it happens, the first level after your retina, already there's a downsampling, a 10-to-1 downsampling. And so the retinal cell firings are combined. They're extracting information and compressing it, and that before it even exits your eyeball. And then on the nerves, on the way back to your visual cortex, your V1 and your motor cortex, there's additional things happening.
Yeah.
And there's also, your brain is also reaching forward to your retina and adjusting at least your pupil based on high level things. So if I show you a photograph of the sun, your pupil will constrict. It's changing the incoming information, the amount of incoming light based on a high level category. And so there's information traveling back and forth dynamically as you're processing.
So it's a two-way conversation between the retina, the optic nerves, and the brain. There's a two-way flow, the data flowing in, but it's being guided by instructions, if you will. And is that how attention works? Is attention is presumed to be governed in somewhere in the brain, not out in the optic nerve, for example?
Yeah, I mean, there's thought to be both top down and bottom up attention, and so there are properties of the world that will capture your attention. One of the well, so these things have been studied a lot in the lab. They were also sort of incidentally studied by people trying to get you advertisements.
Mm-hmm.
Things pop up on your phone, and people were testing what was capturing people's attention. But for example, one of the best bottom up signals for attentional capture is looming, when something gets bigger. And so if something grows in size, it's the old John Handy joke. The joke. I wondered why the brick was getting bigger, and then it hit me.
Yeah, and I'm
And
also reminded of the video technique. Even Apple videos will sort of have that fade up where the image will come across to you and getting bigger. So that's grabbing your attention. I've also heard that novelty tends to grab your attention, right? Something new.
yeah, novelty can grab attention. So there's a whole sort of collection of things that can grab your attention, guide your attention,
Yeah.
and then there's also the top down things. If you're looking for your friend at a crowded train station, you can use the sort of their face template to guide your attention and think, all right, that can't be it, that might be it. So there's both this top down ability to direct your attention, and then there's bottom up properties of the world. And that looming example seems to be present in fish, in insects, and birds. I think there's an example in one of the Indiana Jones movies where he opens his umbrella at the pigeons to make them fly up and into the propellers of the airplane, and that works.
Yeah.
They also have that attentional capture. It's a simple low level cue that also partly explains why fireworks are captivating. Is that they have
Ah.
this looming on the sky, and that captures our attention. It's
Yeah,
something.
we had our 4-year-old, 5 and 4-year-old grandchildren at fireworks recently, and the little girl was saying, "It's coming at us! It's
Yes.
coming at us!" Yeah, looks like it's coming at us. So, and I can understand from a evolutionary biology standpoint why there would be an advantage. You're going to pay attention to things that are coming at you, because if it's a predator, you want to know so you can do something about it. So you could sort of understand why maybe evolutionary features are built into the brain that put extra little energy on that looming effect to grab your attention, because it's a symptom that something might be coming that you ought to know about. So that sort of makes sense. Yeah, that sort of makes sense.
Yeah.
And the attentional focus, it reminds me of I'm sure you know the video, which is very popular, where you're told to pay attention to these 5 people passing a basketball around,
Hmm.
and you're paying attention to them passing the basketball around, and you do not even see the guy in the gorilla suit going by. So it shows there's a plasticity to attention, I guess, that's and how does the brain sort through all that to make those choices about what to pay attention to and what not to pay attention to?
As a fun aside, I know two of the people in that video, and it was shot in the lobby of William James Hall, the psychology department at Harvard. And the fellow who was doing those studies taught me for my cognitive psychology class in my sophomore year of college. So he had lots of. It was almost like watching America's Funniest Home Videos, but he was then explaining what it was telling us about attention and how our minds work. And so one of the people that's in that video did his PhD at Harvard and then a postdoc at Yale in the same lab as me. And so he then turned some of those phenomena into simplified versions, lab versions, where he would go out to Times Square and give people a tablet and then see how many of them noticed X, Y, or Z, and what properties would influence it. And so, yes, so most of them, when you figure out, this is a property that captures attention, it seems like you can quickly come up with a reason why that would be a useful thing to have attention drawn towards. Sort of
Yeah,
a
and very useful for marketers and web designers and anybody else that wants to grab attention. Very useful knowledge. So, but what does it tell you about the structure of the brain and what's going on?
there's sort of ongoing debate about why exactly our attention is so limited, or our conscious awareness is so limited. And many people have had experiences either remembering a dream or lucid dreaming, or sort of, I don't know, quasi different types of states where they feel like they're aware of more. You feel like there's, like the question is, why would we be so limited? Why could we only be sort of really aware of one thing at a time? And psychologists have quantified that. There's this sort of famous paper, the magical number 7 plus or minus 2, which is about how much we can hold in our working memory. In terms of attention, it seems like the magical number is something like 3 or 4 objects that we can attend to at a given time. And even then, it's really 3 or 4 spatial locations, but only one identity. So you can only really consciously be aware of the identity of one thing at a time, and you can shift that awareness about. And so, why is it that limit exists? One hypothesis is that it's about action, and that you can only really act upon one thing at a time. Imagine that you were simultaneously trying to act on a peanut butter sandwich and a tiger. You can't approach and avoid at the same time. You have to choose one item to act on. You have to go towards it or go away from it. And so there's a bottleneck in action that we have. We have sort of our body has to do one thing or another. We have real difficulty trying to do two things with our bodies. The famous pat your head and rub your stomach, or try to make your hand. I've practiced this overtly, so I can make my hands go in opposite directions. But as soon as the first time you try to do it, everybody ends up going in the same direction. You can't get two motor commands out at the same time. So that's one hypothesis, is that the awareness is limited by this need to feed our awareness into action, and so that could be sort of a justification, an engineering type of justification for the limit. It does also seem as though what we're conscious of to learn something new, so one-shot learning or practice learning, then can be offloaded into the unconscious. And so then it can become sort of automated. You think about way back learning how to drive. Everyone learning how to drive is really struggling, especially back when we used to drive stick shift, right? It's like, we got to put the clutch down and press the gas, and it's all almost overwhelming. But after a bunch of practice, you can drive from home to work and, forget that you were supposed to be going to the gym because you were on autopilot. You're just executing all these things almost as automated routines.
Right, and that's what the process with athletes. I mean, you can't, if you look at a basketball player who is making shots, that process is automated. He doesn't think about it, and if he does start to think about it, it falls apart because that attention gets in the way of the automaticity. I mean, they talk about the yips in golf and these things that if you start paying too much attention to things that are otherwise automatic, or even walking, if you start thinking about placing your feet and balance and all that stuff, it can confuse the process of walking. You become less stable. So, that's interesting. So a lot of what we do physically is automated processes that we've learned. And now is that processing still taking place in the brain, but it's just below the conscious level, or is it take place out in the extremities? I don't know the answer to that.
It's still in the brain. The muscle memory is not in the muscles. It's in the cortex, and possibly in some cases the cerebellum. Yeah, but it's outside of conscious awareness, and that sort of frees up conscious awareness to think about other things, to learn new skills.
Yeah, I've heard it described as a process where you have a lot of neural inputs going on, and then there's some sort of filtering process going on in your brain that decides what to get queued up, what goes up this chain, up the chain, and actually goes to the attention, to get the attention. Is that a useful way of thinking about the process?
Yeah, there are a bunch of metaphors that we use to try to understand attention, and filter is one of them. Another one is attention is like a spotlight. We're sort of shining our spotlight towards things, and you see what's in the spotlight, and you don't see what's outside the spotlight. You're not shining it on the gorilla. You miss the gorilla entirely. Another model is that it's almost like we've built up a virtual model of the world inside of our minds, and we're inspecting it. And the attention, when you attend to a particular object, you can get a sense of whether it's smooth or heavy or cold or hot. Looking at it and directing your attention there, and it's almost as though you're reaching out and grabbing it. And so, in some sense, you can understand how the Greeks made their mistake of thinking that we were projecting light out into the world, because there might be a real sense in which the model inside of our head is being interacted with by other parts of our head in that type of way. We're sending attention into the model of the world in our head. We're reaching out and grabbing things in a sort of simulation of the world. Yeah. And that's not that far off. Just that the rays aren't going out of our eyes into the real world. Yeah. Attentional signals are going into our model of the world.
Yeah, that reminds me. We had a speaker, I think it was Blue Knight, on this show that was talking about active inference, which is a type of modeling now used in complexity science. That there is the agent who is perceiving the environment and is creating a model of that environment on which to make decisions. And when information comes in, there's an effort to check the information relative to the model, and sometimes the model has to get adjusted, and it's presumed to be a Bayesian inference process to make those adjustments to the model and then update the model so that the agent can then make better decisions. So at least from a conceptual standpoint, can work for thinking about the human brain. Is that right?
Yeah, that's right. I think a lot of cognition, a lot of perception involves inference. It involves sort of, you don't know what's beyond the edge of this screen, but you assume that the bookshelf continues and there's more books. If I tilted it and there was a bunch of spaghetti there, you'd be very surprised. You've automatically generated inferences about sort of extending the world, and your brain is doing that all the time.
Right. So you've got that model that's going on in your brain, and when something is at odds with that model, you pay attention, right?
Yeah.
Yeah. Okay.
Yeah, pay attention.
Yeah.
And they call that sort of a reward prediction error, or prediction error, and that's sort of you're generating these predictions about what's going to happen next, and if you make a mistake, you get a prediction error, and that adjusts your model. And so
that can have not just mental cognitive effects, but it also can have effects on the rest of the body. The emotional apparatus can get engaged if you notice a change in your field that suggests there might be a threat out there, for example.
Yeah. So if you weren't expecting a threat and suddenly it appears, it's also worth noting, I guess, in a timely way, that this is a big part of how the current generative AI is working.
Yeah.
Is that they are trained on a huge body of text or a huge number of images, and then you can set it up so I show you part of an image and try to predict what the rest of the image is, and then actually reveal it and alter the model to try to accurately predict that, and do that over and over again until the predictions get more and more accurate. And then you can say start a pattern and try to complete it, and then you get sort of these generative both text and pictures. I'm especially impressed by the OpenAI's DALL-E, which takes a verbal prompt and generates a picture, and you can give it style guides and say, paint me a picture of Salvador Dali looking in the mirror and seeing a robot looking back at him in the style of Salvador Dali. And it does an incredible job. It takes that text and generates an image.
Yeah.
And it's been trained to try to make predictions on what sorts of captions will go with what sorts of images. And it's got a sophisticated process to generate those images, but
I think that's
prediction.
Absolutely fascinating in AI. And I just read recently about the ChatGPT, the thing that's gotten a lot of press. That what they're finding out is the more sophisticated reinforcement learning you apply to an AI to try and get it to be more responsive and better responsive and more intelligent and all that stuff, is it a new feature shows up. It's called sycophancy bias. because the AI is learning really well how to please the people that are training it. So it's a social learning context. It makes it less reliable because you don't know if the answer is true or false or just what people are wanting to hear. That's a lot like how people work, right? Yeah,
Yeah,
yeah.
unfortunately.
So here's a question. Now, in the attentional process in the human brain, what's paying attention, or who's paying attention?
And I think both your conscious self can pay attention. That's sort of the top down attention, and a bunch of modules that are built to monitor the world and detect threats and detect things that deserve extra processing, whether it's something novel or something potentially dangerous. And so I think that there's attention at multiple levels. There's the conscious you paying attention, and then there's these preconscious or unconscious perceptual modules monitoring the world around you and monitoring your body. Right? Like another thing that can capture attention really well is pain. You put
Mm-hmm.
your hand in ice water and you can't think about anything else. Your attention is entirely focused on how to stop that.
Mm-hmm.
And so I think, yeah, the who is often the conscious self, and at the same time, there's other processes that are beyond your awareness until they deliver the information that
Mm-hmm.
they think you should focus on, or they're
Yeah.
designed to deliver to your conscious
Yeah. And
awareness.
part of the controversy is over the characterization of that self, the conscious self. And, do you have any, is that epiphenomenal to these physical processes that you study, or is there some noumenal sense of self? What's your feeling about that question? I know it's a big question.
It is a big question. I mean, I feel like you could try to understand the self from a natural level. You could try to understand it from a spiritual level. And if you're going to have a complete understanding, you're going to want the two of those to be in alignment. And so, from a natural level, you can think about self sort of emerging over the course of development and the processing information, being able to make predictions. So, in the case of, is there a self to exhibit free will? You have to think about, well, how does the self come online? How does it come to both know about the world, be able to make predictions, and then be able to make decisions that change the probabilities of things that are actually going to be causally efficacious in the world? And the development of the I over time is fascinating. So
Mhm.
how do you become self-conscious? How do you become conscious of other people? How do you become conscious of the physical attributes of the world? And you can study that. You can see sort of how babies think about the world, how they think about themselves, how they think about other minds. There's a whole field in psychology called the theory of mind and development
Mhm.
of theory of mind, about how babies and then infants and then toddlers come to understand their own minds and how their own minds differ from other minds, and come to be able to have some self consciousness, to be able to. There's also sort of self recognition in a mirror. Say like that's me. I'm responsible for these actions, and so that trajectory of coming to represent your own self inside of your mind is a fascinating developmental trajectory.
Mhm.
And then you think about, well, now what am I able to do with that self, that to understand possibilities and to say like, I want to do this thing. I want to graduate from college. I want to plan a trip to Bermuda. I want to. You can imagine possible futures, and then you can take actions that will lead you to those futures.
Mhm.
In that sense, you can think about the self as as developing and then maturing and then taking on this freedom and responsibility. And I think that once you get to that point, you're very well aligned with a spiritual notion of the self, and thinking about to what extent do ourselves transcend our material bodies? What aspects of my self, my desires, my beliefs, my the things that I love, if you replaced every cell in my body one at a time, at what point would I stop being myself? Maybe never. Maybe if I still loved the same things and wanted to do the same things and had the same feelings, you'd say that I myself had transcended my physical material makeup. And so I think that yeah, that's a very long-winded answer to
Yeah,
it.
well, you've delved into some area that I wanted to ask about, and that is that sense of self. Some people claim is really an illusion, that the whole process is being driven by the body, and that there's then this sensing at the top of the heap here that is recognizing what the body is doing, but thinking it's responsible for that, whereas it was really the physical processes leading up to it that led to this. So this is kind of the determinism model of the human not really having a self, but we're interpreting these things that happen in our body as if they were, choices being made, when actually it's being driven upstream from all the neural inputs. Sounds like you kind of go the other way, in the sense that, well, yeah, there is something that makes those decisions and choices.
I mean, when you look at the architecture of the brain, there are many more connections going from the top down than the bottom up. People had these initial feed forward models of perception and cognition where information was just flowing in, and then something would happen at the top. But really, as I mentioned before, even in the case of vision, that your high level cognition reaches back down to the pupil and alters the incoming information, and that the high level sort of things that you think about, that that you want to do, are in many ways can become in control of your actions, mm-hmm. and guide what you attend to. Mm-hmm. If you want to attend to the beautiful things in the world, take any part of the world, and there are some things you can attend in that scene, even a very difficult scene, that are beautiful, and you can decide, I'm going to direct my attention to these things, or I'm going to direct my attention to the things that are interesting, that are confusing or mysterious, and we certainly have control over that. And anyone who says that they don't have control is telling themselves, I think, a little bit of a mistaken story.
Yeah.
At the same time, it's possible to have an illusion of agency when you don't really have it. So if I were to hit the table right now and the power went out in your room, I would feel like, wait a second, did I just do that? Did I? You can mistakenly feel as though your actions are efficacious in ways that they're not. You can have causal mm-hmm. illusions about you.
Yeah, and that's one of the determinist would make the accusation that we're built to be agency detectors, so we'll just we will detect things happening out there and assume that there's agency behind it. It's like when children will see something that we know is just a random event or an accident or the change in the weather, and they'll sort of jump to the conclusion that there's agency there. But it sounds like part of this, if you accept agency on your own behalf, you quickly learn as a child to begin accepting agency on the behalf of others, and so understanding, well, I have a mind that makes choices, others have a mind that makes choices. So then you can start externalizing that sense and believing in the agency of others, and sometimes making a mistake and believing in the agency of your fuzzy toy, or your snuggly, but that's part of the human process as well.
Yeah. I think it's worth noting that there can be illusions, right? There can be illusions of mm-hmm. of willpower or will efficacy. There can also be visual illusions, right? We know of lots of visual illusions. That doesn't mean that all of perception is malarkey.
Yeah.
Right?
Yeah.
The fact that there's visual illusions is in stark contrast to the typical reliability of vision. And everybody has the experience of conscious will, of free will, of being able to think, this is what I want for lunch, or this is what I'm feeling like. I'm going to make a plan to go do that, and they do it. And that can be on the short term or the very long term. If you were to try to predict where you and I are going to be 5 years from now, for example, or even maybe 6 months from now, there's no physical model that could possibly make that prediction. You could have a model with every atom in the universe and be trying, and there's noise in those models because uncertainty principle and things like that, but the model would just fall apart pretty quickly. You'd have to abstract away, and in order to get the most accurate predictions about your mind and my mind, you'd have to have access to our mental representations, to the things that we want, the things that we desire, the things that we love, the things that we want to spend our time doing, to our goals. And those are not physical concepts. I mean, you can try to describe a goal or what somebody loves in terms of atoms, but you just won't. You'll never get there.
Yeah.
You have to appeal to a mental level. And at the mental level, you can make predictions that are unavailable to a purely physical level. And I think that's really powerful. It says that we don't have to privilege a physical Laplacian demon billiard balls bouncing, because that model just fails. It's in our universe, that model does not work. You might be able to make a computer-based universe where determinism holds, but it's not our universe.
Mm-hmm.
We have probabilistic laws, and in order to make accurate predictions, you have to appeal to multiple levels of structure. In some cases, atoms; in some cases, biological structures; in some cases, minds; in some cases, civilizations composed out of minds.
Two questions. One is there's more study now about conscious behaviors in animals. And all the way down the chain. I think you used an example of fish vision having some similarity to human vision. Do you this issue of consciousness, self-awareness, self-consciousness, the self, is that a continuum across the animal world to humans, or is it or is there a discontinuous jump at a certain point where you go, wow, that's self-conscious, that's self-conscious?
I think that it's an open question. So, I mean, if I told you I knew the answer, then
No,
I'd
I'm
be.
asking for speculation. What do you think?
Yeah, so for speculation, I mean, I think that there are. So you can take any dimension of consciousness, and when we say consciousness, we typically mean a whole bunch of different things.
Mm-hmm.
What it feels like to be me, the narrative voice, the things I tell myself about myself, the culture that I've learned, my awareness of the world around me, um, the the intersection of all of my memories with my current input. Right there's when you look out in the world and you're recognizing things, you've got sort of part of your entire past experience is coming to bear on the present moment.
Mm-hmm.
Just looking into your office or looking out the window, your history is intersecting with the present in your conscious awareness. Um, but you could break down different aspects of consciousness and say, well, the ability to feel pain, for example, or the ability to want something, or to sort of
Mm-hmm.
feel approach a void, or to say to be able to abstract away from something and refer to it symbolically with a word or a beep or a boop or
Mm-hmm.
something that doesn't look like that thing.
So is that abstraction, I know, is an important step. We don't think we think of bacteria as sort of wanting food, and they will mobilize towards food sources. So there's a wanting aspect to that, and in animals you can see a lot more sophisticated behaviors around that look like desires and intentions and choices. But this issue of the self-awareness of agency, is that that sounds like maybe it's a little bit more like a discrete change from at a certain point you really don't have that, and then at some point you can abstract, you can create language, you can get to a different level of that self-awareness. So that maybe there is a discrete jump at some point as opposed to just a continuum process.
It's tough because I mean, I think that if you looked at the animal kingdom, you say all of my data points will be living creatures in this world. Um, well, then you'd also have to say, under what conditions? And
Mm.
what about a sleeping human? What about a newborn baby? What about a toddler? What about a 150-year-old blue whale? What about so you could take it, use different types of animals as your data points and say how much consciousness is there, what types of consciousness is there, or even for an individual person, if somebody has a frontal lobotomy, or is currently in a comatose state, or is in a coma but has some amount of readout through some brain imaging that can let them communicate with the external world. How conscious are people under these different conditions? And so it gets really hard to say there's a phase change or a
Mm-hmm.
complete step. It does seem like that happens for us from falling asleep and waking up. That's a phase change. It would go from
Mm-hmm.
unconscious to conscious. That seems like the best example of a discontinuous
Mm-hmm.
um, transition from unconscious to conscious. Um, but I think it gets tricky when you have to try to include, say, newborn babies up to adults. And it gets tricky when you think about complex animals that have sophisticated brains that we don't know how to ask them questions or how to probe their awareness. I wouldn't be surprised at all if whales have pretty rich experiences, memories. Same thing with
Mm-hmm.
elephants, dolphins. Right? There's probably a lot of consciousness inside of their minds
Yeah.
it's not the same consciousness as ours. It has things in common. And then you could think about, if there was a hypothetical alien intelligence, what would its consciousness possibly have in common with ours?
Right.
And
I know
so,
there's controversy over octopuses. Like they have such different neural structures, but there's recent, discussion about maybe, maybe they have an entirely different kind of consciousness than we do because it's a dispersed kind of thing. But we ought to be paying more attention to that. That's kind of interesting. Yeah.
It's very interesting. And I mean, even between two people, we sort of assume everybody's consciousness is very similar. I think even individual people can have fairly different conscious experiences. I think people that are neurotypical versus atypical, somebody with ADHD or autism, I imagine that their conscious experience has a lot in common with mine and a lot that's different. And we don't know exactly what all is in common and what's different. And I think that in the medium term future, we're going to be asking these questions about artificial intelligence. We'll say, it might be conscious in a different way than us, and it might exhibit some aspects of consciousness that we think are really core to our type of consciousness, and not exhibit other types. And so, trying to parse what each of those pieces is when we're dealing with consciousness, which also has these interesting holistic properties, right? Maybe you need all of them to say this is a fully conscious being, or this is a super conscious being, or something like that. It gets tricky when the parts don't always add up to the whole. And when you take subsets, they exhibit sometimes different properties than those same subsets combined with a different set of subsets, and it's a really challenging.
Yeah, concept. And that's part of complexity science. A network will get to a certain level of complexity and interaction and sophistication, and all of a sudden new properties arise that that we didn't know about before. And then each network is nested to another level of network, and the human brain has to be one of those, really, which is a network upon network upon network upon network, and it's really, really difficult to see. We can see the end result, or we can experience the end result, but seeing how all the pieces fit. And that actually leads me to another question: is are we gonna, are we gonna figure out the human brain? Is it a solvable question, and or are there always going to be open-ended aspects to the inquiry that have to be a lived experience rather than a scientific experimental, study or laws that kind of define how this process works? Is it an answerable question?
I think that we'll continuously make progress, and that it'll also be a moving target to some extent. And so we'll understand certain aspects of the brain and the self, and then the brain will change in certain ways, and the concept of self will extend in certain ways. You could ask. I'm getting ready to teach cyborg psychology this spring, and so we grapple with a number of these questions. Is your phone part of your brain? What about if you're wearing glasses, does that mean you're a cyborg? And I think our sense of self is intertwined with technology in some interesting ways, right? Not necessarily your conscious experience, but your part of your mind that you think of as cognitive, your memory, your decision making, your ability to process information is both inside of your brain and it's in your social network. You have a friend that can solve a certain type of problem. You don't have to learn how to do it. You can ask them. They call it transactive cognition or transactive memory. Your spouse remembers some events better than you. And you don't focus on all the details. You'll ask your spouse what it was like and who was at that party. And so we externalize aspects of our cognition and in some ways aspects of ourselves to other people and to technology. And so a brain sort of in isolation, even if you understood it sort of completely in isolation, you wouldn't have a complete understanding of people. And so psychology is not going to finish with a complete description of brains and connectomes and all of that. There's still going to be an ongoing
exploration. I've sometimes talked about sort of the issue of, there's consciousness, there's meta-consciousness. We're aware of our awareness, and then the awareness of the awareness of the awareness. You get into an infinite regress. Well, I think you're expressing the belief that consciousness studies will be an infinite progress. never ending in a sense. I know you've spent some time studying physics, right? So how about physics? Is physics subject to the same set of conundrums or limitations that, it will always be a future moving target? Or is that something where you think there will be, kind of the definitive theory, physical theory of everything, where, the quantum physics is going to be integrated with classical physics and everybody will be happy?
I mean, in terms of a grand unified theory that unites quantum mechanics and the standard model, I wouldn't be surprised if we achieve that. And I would say that the game won't be over yet. There'll still be open questions. I guess a collection of questions. There's one is, will we ever have the complete set of laws of the universe, which would include, quantum mechanics and the standard model? And if we did, would that mean that we knew everything there was to know about physical things? So imagine that we did. We'd still have the universe is expanding, and the observable universe is expanding. So the map of the universe will constantly be expanding, and maybe new things will show up in that map that we hadn't anticipated before. And I think that there's always going to be new horizons to
Mm-hmm.
explore. And I also think that the more is different principle, that you can understand everything there is to know on one level and still not doesn't necessarily tell you everything about the next level. So, for
Right.
example, phases of matter. We think of there being just a few phases of matter, of solid, liquid, gas. But if you ask the plasma physicists, they'll say I forget what the number is, 27 phases of matter,
Yeah.
and there's quasi liquids, and and you can't always predict the properties after those phase changes. So you'll have
Yeah.
superconductors, and maybe you wouldn't have predicted superconductors from the standard model. You have to have another set of things to understand them,
Yeah.
and you'll get emergent types of behavior at the biological level that seem like they're overcoming the thermodynamics, the laws of entropy, right? That these processes are unfolding in a way that's concentrating energy, and that's creating order, and not deteriorating into disorder. And so you'll get pockets of sort of things that seem to violate those principles of entropy. And to understand those, you can't just say no entropy. That's the end of the story. No, you've got to understand things on the levels. And I think that as complexity layers on top of complexity, each level can have its own science. It can have properties that you could not have predicted from the complete understanding
Mm-hmm.
of the lower level. And so, in that sense, I think your conjecture that we'll have infinitely progressive understanding of things at more and more complex levels seems right with me. Yeah.
So, and that's great. Thank you. Now here's the question: the fact that there may be no end in the inquiry, or there be no clear answer, definitive answer. That can be a little disconcerting to humans like to have answers, and to think that it's sort of a never-ending process can be a little disconcerting. So I just wanted to ask a few questions about how you kind of make sense of that. And one way is to just you grew up in a religious tradition, and what do you feel? How do you feel that helps you make sense? Has that evolved as you've worked on these fields of complexity, and this idea, as you expressed it, of sort of an infinite progress agenda for the future? So just tell me a little bit about your background and how that informs your current beliefs.
I think that there's a strain of thought within academia and philosophy of there is no underlying purpose to things. It's all random. It's these laws. It could have been otherwise, and I find that really just unsatisfying. I think that when I try to understand myself, the, the natural world, the universe, and metaphysics, that the most satisfying conceptual framework for me is a divine being that created order and that loves us and wants us to explore and understand more and more, and for us to make progress and face challenges and overcome those challenges. And so, if you think about when Newton was thinking about the laws of gravity, for example. And he was like, where did that language come from? A law. The law is, who made the law? And he said, well, a deity made the law. God made a law. And so to try to understand science as a window into a higher order of sophistication and knowledge and lawfulness, I find really fulfilling, motivating. I guess it seems like the right way to think about things. And that when I imagine, what could be the law underlying this natural process, or how could this seemingly chaotic or in some ways seeming random or noisy behavior actually have a lawfulness to it, it helps me make progress in understanding things. And in a sense, if you think about sort of the net sum of all the regularities of all the laws as being a window into the mind of God in some ways, that feels unifying, and as a framework that drives science forward. Mm-hmm. There's always more to learn. There is underlying lawfulness and order beneath the apparent chaos and randomness. I find that sort of worldview intellectually satisfying and motivating. It helps me sort of make sense of science and look for bridges that connect different levels in science. And that's only a small part of an answer to your
well, that's question. A beautiful answer, and I think it's kind of says science is a quest for answers, and if the answer is it's random, that's a very unsatisfying answer. I think it's kind of the way you put it. I really think that was beautifully said. Different question that I like to ask. Have you had an experience in your own life that you find either sort of unexplainable or mystical or transformational, something really important that came from, either random or unknown or whatever? I mean, just sort of an experience that you felt was really important in your life and you don't necessarily have a good explanation for it.
I feel like I have these experiences almost every day, and not that you couldn't explain them in a material framework, but those aren't satisfying explanations to me. When I open my eyes and I see the world and all sorts of, infinite complexity and beauty in the world, and I feel grateful for that, that to me is a spiritual experience. I think of this as praying with my eyes open, and I spend a fair amount of time in nature and with my family praying with my eyes open, seeing, taking in the world and understanding it as something wonderful to be cherished and grateful for. And I feel like that experience feels transcendent. It feels like I'm appreciating things in a way that is not accessible from a different worldview that thinks, this is all just random and this is meaningless. And so I feel like I find myself in those states of reverie, of appreciation. Ideally, many times over the course of a day. There are days that go by when I get stuck in a rut and I'm working on something and I think, wait a second, I need to step back and take it all in again. But I feel like those experiences don't have to be unusual or extraordinary in order to be powerful and transcendent, and that we could seek them out by praying with our eyes open, by putting our minds into a state of appreciation and wonder and curiosity, and just looking at the world around us and then feeling, appreciating it and feeling grateful for it.
Beautifully said. Just beautifully said. And I know you experienced that, particularly engaging with your children. For me now, it's my grandchildren, and you can't explain how wonderful those experiences are. Justin, this has been fantastic. It's been a great conversation. I really appreciate your time and your heartfelt contribution to this conversation and being willing to share with me. So thank you very much, and we hope to stay in touch.
Well, thank you for having me, and I hope we can do it again sometime. Take care.
Thanks for joining us on this episode of Making Sense of Complexity. Join me next time for a conversation with noted mathematician and author of The Outer Limits of Reason, Dr. Nassim S. Yanofsky, as we discuss the astonishing complexity in mathematics and computer science and the mysterious paradoxes in logical reasoning. In the meantime, please explore the websites of our collaborators, Complexity Adventures, Planksip, and Talk of Today, and join the conversation on our social media outlets or on spiralinquiry.org. Stay well and have a great week.